Good morning, and thanks for having me here at Laracon. I'm just going to confess right up front that I don't know very much about Laravel. I work with someone who is very keen, so I suspect I'm about to know a lot more in the coming months at work, but right now, I don't have a lot of Laravel context. But I do know a few things about Git, and you've shared so many ideas with me about the technology that you're excited about. I've come to share some ideas with you. I'm going to be talking about advanced Git. I have been assured that, for the most part, you are not beginners with Git. So I'm hoping to show you a series of things which will help you in your day-to-day work. It is literally a series of things. So if I lose you at any point, relax, and look out for me starting on a new topic. They don't build on one another. So if you're feeling lost, the next thing may be more relevant to the work that you do. Before I dive in on the command line, I want to say this about advanced Git. Really advanced Git users are advanced not because of the commands that they know, but because of the way that they use the tool. They are curating sane commits, putting together sensible units of work with a commit message that makes sense and will mean something to us when we need to go and dig into it in 3 months' time. They are people who branch and merge effectively in a way that reflects the bigger goals and the work that we're trying to do, rather than the fact that you should commit your code before you leave the office. So I wanted to start by just kind of showing you around, really, with Git and some concepts that I think will help you to put these other pieces into a useful format. The most observant amongst you will notice I'm now at the command line. That means there are no slides. So if you see anything you like, you probably need to write it down or something. I could share my slides. There are 5 of them. I'm not sure how helpful that will be. All right, so let's just start by initializing a new Git repository. That's given me a Git repo here in the my Git directory. It's empty, except it's got a .git directory, because that's how Git works. And inside this .git directory, we will see a bunch of things as branches. There'll be more stuff in there later. Config, let's have a look at the config. This is my config file. It's human readable. You can come here and edit your config file. Until the last few years, you had to. Most of the stuff that people did with Git, they did by moving files and directories around in the .git directory. If I start setting config variables, I'm going to set this locally because I really frequently demo this and then completely ruin my settings for all of the other repos on my machine, which is kind of annoying. If I set some config settings, you start seeing them appearing in the config file. It's a plain text file. Section.setting just reflects in the Git config like that. Everything in Git is an object. And the easiest way to show you this, just going to split my screen for a second, is to show you things as they appear in the objects directory. So we have a look. This is what's in the objects directory right now, empty repo. The info and pack files are always there. If we now use the other, this is the other way for you, this side, and start doing a little bit of work with Git, we'll just get a file going here. I'm pressing tab. Git doesn't know what word I'm thinking of. Come on, Git. And as soon as I start to do add, things start appearing in the objects list, and that's because we are staging changes. Git is starting to create some records that relate to this. If I then commit, then we see more objects appear the next time the watch command refreshes. And those objects If you're looking at the list, you can see all of the things listed there in the right-hand pane are directories. And that's because everything in Git is an object. They all have those long-winded SHA-1 names that you're familiar with from commit references. And they are sort of sharded in storage. So there's a directory for each first 2 characters, and then objects inside that. Because otherwise, on a large repo, you would run out of inodes. If you look at my commit, 7D, 5F, you can see, oh, we've got a 7D directory. The objects literally exist on disk in the .git directory. And that's really all that's going on there. Let's just jump out of Tmux, because otherwise I'm going to end up wedged in one window. Let's think also about branches. If I create a branch, let's actually switch to it. Oh, naming things is hard. Then we start to see things appearing in inside that .git directory. So in refs heads, you'll find all of your local branches. And all these files are a pointer to a commit. There's master. I just branch from the same place, right? So branch 1 points to the same commit reference. So think about this. A branch is purely a text file that lives in your local .git directory and contains, in plain text, the name of the commit it points to. A branch is not a sequence of commits. A branch points to a commit. Every commit has a parent, 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 and we sort of assemble branches by computing this. You'll see this branch pointer move around later. I think it's a really important concept to understand. Okay, some things I want to share with you that might happen in your day-to-day work. Watch really closely, the script name might give you a clue. So, these are scripts which are aimed to be easier to watch than me typing, but I just kind of turned on the output, so I'm not sure they're much easier to watch. Initializing an empty repository called branched, and then copying a script in and committing it that we're going to need later. For reference, weird things happen if you're in a Git repository which doesn't have a commit yet. So you'll notice that every example starts with, let's just quickly commit a thing. And this is to stop me making a fool of myself on stage. I mean, I might, but that's one less thing that I'm likely to do wrong. So we've got that first commit, and it's a script that we might need later. And then I'm bringing in a poem. I don't know if you know the poem, The House That Jack Built. It's one of my favorites because it reminds me of open source. Why is this like this? Well, we used to have a problem with the data format, and so when we tried to fix the time zones, then we added this intermediate thing, which right, so the poem is about the cat that chased the rat that ate the malt that lay in the house that Jack built. So it's like the story just gets longer and longer, just like the history of open source projects have all of these stories. So I am committing this poem, creating a branch, not checking out the branch, and making some local modifications to my local version of the poem. So if we look at house, that's my poem. If we run git diff, this will show me the changes that I have local on my current working directory. Note that if I switch branches, my working directory comes with me. So you can develop on the wrong branch as much as you like, as long as you're on the right branch when you commit. So git diff shows me this is what's here, and git status shows me I have house.txt modified. Someone commented when I was teaching Git recently about how often I run git status when I'm teaching. And I had to say, no, that's an average day in the office. Git status, what's happening? Git status, what's happening? Do some more. Git status, what's happening? It's a nervous tick, but one that helps me to remember where I am and what's happening. Here's my favorite Git Add feature. So if you do Git Add with a file name, well, that's fair enough. It's a normal way to work. If you do Git Add with dot, I'm going to controversially say that this is for losers, and you can do enormously better. Try this, Git Add with -p. This allows you to review each of the changes that you made. And you can review each one in turn, and you can choose to add or not add each one. I find it also means that I make eye contact with the var dump statement, which is lurking somewhere in a file. So I find that incredibly helpful, that the var dump statement kind of gives me a wave on the way past when I'm doing Git adds with dots. So I will say, there's a bunch of things you can do here, right? Yes, no, and quit are the first three. They're basically the ones you want. Press question mark for all other options. I will stage this change, and let's not stage that change. Have a look at what Git status shows us. That file shows as both modified, this file shows as both staged and unstaged, because part of it is staged and part of it is unstaged. You'll see this also if you add a file and then edit it some more. So the staging area allows you to pick just the changes. So you can create really good commits without having to do your development thinking that way. You're the craftspeople. You make it awesome, and then Git will allow you to communicate that any way that you want. If you stage something you don't want to, Git Reset will unstage your changes but doesn't lose them. So Git Diff is still there. We can add with the file name. We can also Git Reset with -p. So it'll allow me to unstage individual changes. So if you kind of want everything except not this bug fix that you did in a long file, you can just add the whole thing and then reset with -p. You can check out with -p as well, if that's helpful. I am staged. Awesome. Let's stop fiddling about with that. Okay, so what I was going to show you was a merge conflict. So to do that, I am going to switch over to that branch that I made earlier. So we did a commit, then I created a branch. You've just seen me make changes on the master branch. Now we're going to make changes on the feature branch that I've called awkward to give me a clue that something might happen. I have brought in some changes, and I have committed those changes. So Git status just shows me everything's cool. Now, if we switch over to the master branch, come on, then let me show you my favorite Git command. It's a tough call. This is my favorite Git command with all of the switches and everything. This is harder than you would think. Decorate all graph. Those 4 switches, git log, 1 line, decorate all graph. I'm typing it once, and you'll see me pulling it out of my history with Command R for the rest of this session. And what this does, the 1 line shows you the compressed view, so you just get the little bit of commit reference and the first line of the commit message, or the first piece of the commit message. Often we don't care about dates or authors or whatever. It allows you to see more than 4 things, rather than trying to look through a letterbox. You can see a long history. The decorate is what produces the branch and head and tag labels. So you get those green, red, I haven't got any remotes, red, and the head label. --all means show me things that are in my repository but which are not necessarily ancestors of my current commit. So usually Git log will just walk back up the tree for you, whereas here, if you've branched, it will show you all of the branches with --all, and --graph does the Ascii art. You can get GUI representations of all of this. I am a command line person, and the command line will work on all of your systems, so I quite like to use it as an example. So we made this awkward branch. It's a feature. It's fabulous. So we're going to merge it now. Git merge, awkward. Uh-oh, there's a conflict. Surprise. You have a couple of options when you see this. Well, 3 actually, but the first one is panic. The second one, you can see here that my prompt says I am merging, so I have that plugged into my prompt. Git status will tell you you have unmerged paths. So that tells you your repository is halfway through a merge. You can't do anything else until you get out of this situation. So one of your options is git merge -- abort. Pretend that never happened. What this means is that now you can go ahead and try and merge any branch in the world ever, and if something goes wrong, you can just walk away. Repo inconsistent state, pretend that never happened. It's also useful for situations like the colleague whose branch this is is in a meeting or in a different time zone or currently at a conference, so we can't ask her what we should do. There's all sorts of reasons you might want to abort. You might want to know how to actually resolve it as well, so let's go for that. Git merge awkward. Oh, there's a conflict. Okay. Git status shows me which file's conflicted. Obviously, this is a trivial example, so we have a whole one file and it's conflicted. But if you have files which are okay, they will show as staged for commit, and only the file or files which have caused the conflicts will be listed here under unmerged paths. And all you need to do is edit the file. Now, I always do this the same way, and I'm going to share my process with you. I search for 4 equals signs if I'm working with code. Doesn't always work so well on various, like RST uses it as a title thing. But on code, I use 4 equals signs, and I search for that. Okay, in this case, the conflict is on line 2, so we could probably find it without the use of search, but bear with me. So we fix this by doing something that makes the code read correctly. And we're done, right? Resolve the conflict, save the file, ready to move on? Before you leave this file, press find again. Because look, there's another conflict in this file, and it was below the fold. And Git will let you add and commit those conflict markers. It'll be just like, Git is not on your side always. So yeah, there's another conflict in this file, and this can happen if you have long utility files or, there's just a couple of, it's a bit of separation between 2 things that got changed. I'm trying to do something specific with this merge. There we go. Search again, can't find anything, so my file is fixed. Now, Git status is totally your friend. Conflicts can be like, oh, there's a conflict, I don't know what to do. Git status tells you what to do. You see the conflict notification, you run Git status, you understand what has conflicted. You mend the conflicts, you save the file. You run Git status. Git says, you should use Git Add. Oh, Git Add. Then you run Git status. And Git status says, you should use Git commit. Okay, Git commit. And there we go. We've resolved the conflict. This is the commit message that you would have got if there had been no conflicts, and it's also got information about which files were conflicted. You can edit this as in accordance with whatever your branching strategy is. If you do fixes, #42, then fine. Do whatever you would normally do here. You know how to do a commit, so there we go. So that's a merge conflict. I have a very clear process. Look at what, if in doubt, back it out. That's going to get tweeted a billion times, isn't it? Oh well. If I always get OH'd on stage, whatever. If there is a conflict and you can resolve it, the conflict is just Git saying, excuse me, I need some help from a grown-up, right? Git can't write code, that's your job. So you need to just pop in and help it resolve where there's been 2 changes that overlap. Add the files, commit the files, all good. And I think this stuff comes up all the time. I wouldn't be particularly concerned that you're seeing conflicts unless you're seeing a lot of conflicts all the time, in which case you need to talk more to the people that you're working with. Or in my case, you need to keep up better with your pull request queue, because once you've got enough open pull requests, they are going to conflict at some point, because they've diverged a long way. One neat trick, if you are seeing the same conflicts coming past again and again, is to do what's called reuse recorded resolutions. This tends to happen where you are building a staging branch or some kind of integration branch, bunch of features available, you put 4 of them on the server, client wants 3 of them, you reset the branch, you put 3 of them on the server, 2 of these branches conflict, and you're resolving that same conflict over and over. It's maddening. There's a feature for that in Git. So to do that, let me just show you my graph. So I have commits on each branch, then a merge commit. I'm just going to undo this so that I can use that conflict again to redo the commit. So to undo a merge, I'm going to do git reset with --hard. My top advice, git reset --hard is really, really useful for losing all of the uncommitted work that is currently in your working directory. It's really hard to lose work in Git, but if that's your aim, git reset --hard will do it every time. If you've committed, we can retrieve it. If you haven't, you just blew it away. So before you do that, git status, nothing to commit, working directory clean. OK, now run git reset --hard. Git reset --hard, and I'm just going to reset the master branch back to where it was before I did the merge, which is that 2823, yeah, whatever. Awesome. So now my graph looks like it did, as if I had never done the merge. Remember that the branch is just a pointer to a commit. So when it seems like a branch is a long thing, and we might be tangling it by going back on itself. We're not. We just move the pointer. That's fine. Right. I need to strategically create another branch at this point. I'm going to call it another. OK. So the record, reuse, recorded, resolution. It's a config setting, so we're going to turn it on. Enabled. True. Got it. Then we do the merge, git merge, awkward. You know what happens. There's one more line in this output, and it's the third one down. It says recorded pre-image. So Git is understanding the shape of the conflict and kind of storing it for later use, or reuse, as the name suggests. OK, so we are now resolving a Git conflict. You just watched me do this. We run git status. We say, oh, look, it's house.txt. We edit house.txt. We find the equal signs. Yeah, whatever. Good, and we say that's perfect, and then we commit it, and that's brilliant. Oh, lovely. So we've done that, and now I'm going to show you what happens when we do the same merge again. So I created the another branch. Let me just show you that log command. Created the another branch, which is pointing to the commit that the master branch was pointing to. So when I merge awkward in, we're going to see exactly the same conflict, exactly as if we were just merging it again. Git checkout another, git merge awkward. Guess what? There's a conflict. But instead of saying recorded resolution, it says resolved house.txt using previous resolution. So it's remembered what I did last time I saw this conflict, and it's just put it into place. Git status shows me it's there, but it's not staged. So I still need to inspect this. I can edit it. It looks like you'd expect it to look. It used the changes that I made last time. And all I need to do is add it as I would, and then commit. So that's using the resetting. If you get it resolving something that you don't want, you can always abort the merge and turn off the setting. It's not on by default just because it's extra overhead and extra storage. And it's only if you have that workflow where you're integrating the same branches repeatedly, usually to build a selection and test it, build another selection. So it's putting together a release branch with a bunch of features in it, something like that. I see this all the time, and it is maddening when you have to keep doing the same thing over and over. You sort of think the computer should be able to help. It can. OK. I'm going to talk about rebasing, and I'm going to talk about it by, first of all, showing you a picture. This is why I have slides, because otherwise I try and do this with the art of mime. It doesn't work as well. So imagine this situation. We've got the master branch or develop or whatever your main line is, and we're happily developing along, and then somebody branches and does some work. Great. Sometimes we'll want to rebase. We might rebase because there's a conflict. We might rebase because we like to rewrite history and make our history look like a happy story where nothing ever goes wrong. Either way, this is what happens. Let me do that again. If I go back one, you branched off from here, and you did some work, and rebase makes it look as if you branched from there. We just roll up your branch, run to the tip of another branch, and then unroll it one commit at a time. If you're rebasing because you have a branch that won't cleanly merge, i.e. there's a conflict, you're going to see a conflict when you do the rebase. The good news, you know how to resolve conflicts. A rebase conflict sounds pretty horrifying, right? But somebody's nodding violently at me from the audience. A rebase conflict sounds horrifying. You know how to resolve conflicts. Git status will show you what conflicted. You will inspect it, you will fix it, you will add it. The only difference is that instead of running git commit at the end, you run git rebase -- continue, and git status tells you that's what you should run next. So don't be freaked out by that because it's super easy. Okay, so git rebase. Here's a script I made earlier. Initializing an empty repository. Here I'm creating a directory, changing into it, and doing a bare initialization. You'll sometimes see this as a bare clone or a bare initialization like this one. And all that means in Git is that it's a repository with no working directory. So typically these are server repositories. They usually have this .git thing in their name. You've seen this on GitHub and so on, where your URLs have .git on the end. And it's a server repo, so you can push to it, you can pull from it, but if you go and try and look at it on disk, it only has the .git directory. There isn't anywhere for you to check out a branch and work on it. So that's really useful for hooks and things. If you want to push to a repository which then has hooks, you can't push to a branch that's currently checked out. So you want a bare repo for that. So all I'm doing is initializing a bare repo, cloning the bare repo. Git very intelligently points out it's empty. Cheers, Git. We do our first commit so that I don't get too tangled. And I've pushed it. So we've pushed that commit back up to the remote. Notice that my remotes here are just local on the file system. Git doesn't actually care whether it's a file or a URL or whatever. It's not that unusual for me to clone, to initialize a Git repo and then clone it and work on it on my own machine. I do it for these talks, so I have a set of scripts, and I'll clone it, and then if I've made any changes to the scripts, I'll add it as a remote and pull them back. Doesn't matter that they're on disk. Also means it doesn't matter that I've turned off my network notifications, so you can tweet at me if you like, but it's not going to come up on the big screen while I'm talking. That was a massive tangent. Okay, so I've committed and pushed. Excellent, everybody's still with me. I've created a new branch on my repo, and I'm using a quick script here that you'll see a bunch of times called generate random changes, which creates a new file, puts random content in the file, and commits it. There's 4 of those. And then created a branch. So I've got where I origin master, so where I did the initial commit and pushed, that's in sync with the origin. I've got a branch with some commits, and I've got the master branch with some more commits. And what I want to do now is rebase the branch I was working on, branch 1, because I'm also awesome at naming things, and rebase that onto the tip of master. When you merge, often you're merging a feature branch into the master branch. When you're doing that, you check out master because that's the victim that you will be operating on. When you rebase, it's the branch that you're making a change to. So you need to check out the branch, it's the victim. I should probably say target. Victim sounds terrible, but I find it much easier to remember. So I am going to rebase branch 1 onto master. So I check out branch 1, and I type git rebase master, and this feedback message is quite a good reflection of what happens. It rewinds the work and then replays each of your commits. So this is where, if there would be a conflict along the way, you'll see that as it does each one in turn. So it'll conflict on one, ask you to fix it, and then the git rebase -- continue is to get it to pick up and carry on again. Let's grab that log command. Here it is. So that looks quite different. You can just see the tail end above where the branch went off and then there was master. And now it looks really linear. All the commits on master happen, and then it looks like all of the commits on the branch happen. So that's rebase. It just lets you go from one thing to another. Did you just lose that? I lost it. There we go. So, what's the point of that? Well, sometimes, yeah, so that you resolve the conflict and then I can accept your pull request into my project. Sometimes it's done for clarity. So it might be that you rebase so that when you merge, you achieve a fast-forward merge. We'll just talk about that for a minute. If I was ready to merge this branch in now, I've rebased it, check out master, git merge, branch 1. Oh, I can't type anymore. It's a long way to go. Here we go. It gives you this fast-forward merge. And what that means is it literally fast-forwarded the master branch pointer to the tip of branch 1, because it was obvious that it could do that. It was linear in our log. So all that's different with our log now is that all the pointers, all the branch pointers are sitting at the top. So that's a fast-forward merge. Sometimes the fast-forward merge isn't what you want. And if that's the case, then you can just do a git merge --no--ff. No fast-forward. And that will always show you there was a branch and you get a merge commit on there. Pictures. So, master feature, if it looks like this and there are no commits on master in the meantime, either because you rebased or because you're doing what I call a hot fix. So you've branched to make a change and merged it back in, but it was a really small change. Nothing happened on master in the meantime. Then all that happens when you do the merge is Git will try to fast forward the merge, and it'll just move the pointer along. Ta-da! If you do the git merge command with the --no--ff, then you get the merge commit. And so your tree will look like this instead, and that's all that is that we get an extra commit, and it's a merge commit with 2 parents, as you would normally expect. So if you see the fast forward and you didn't want it, then you can just do the git reset --hard, as I showed you earlier, and then redo it. I do this all the time. This is my #1 reason for git reset --hard is I merged somebody's branch, and it fast-forward merges. And the branching strategies that I use, I don't like that. I prefer to see the history of that we did branch, and it did happen. One of the clients that I'm consulting for at the moment said to me, we've got a problem. We've got a contractor who is committing directly onto our staging branch, only we sometimes throw the branch away. And it turned out that she wasn't, but she was getting these fast-forward merges, and their branching strategy didn't particularly say to not do that. She was committing on a branch. It just looked like a direct commit because it was doing the fast-forward. So if you read the Git log, it looked like direct commits on that staging branch. So you do see that once in a while. Let's push this. There's another kind of rebase that I wish had a different name, because it's a radically different thing. Git Rebase Interactive allows you to rewrite history. I'm not sure if I should be encouraging to do this, but it's quite fun, so I'm going to show you anyway. Git Rebase-I for interactive. Now this is going to work on the branch that I'm on, so I'm just going to rebase the last few commits, like 8, something like that. So what you get is this text file, and this is your scratch pad. You can move things around as you like here. If you just save and quit this file, then it will replay all of those commits with the current timestamp. So all the commit identifiers will change, but nothing about the actual commits will change. #1 thing to mention about this, because it confuses me every time. You run git log, and it shows you the newest commit first, and the one before that, and the one before that, so time goes this way. This is the other way around. This is telling you a story from the beginning to the end. So you do git log, you decide what you want to rebase interactively, and then it flips it upside down, and your brain goes, wait, what? So look out for that. The instructions for this are all in the comments. So your choices are pick, which means just keep it. You can reorder them, though. So you can pick, move the lines around. Reword for, I should have sorted, that is, I missed the ticket number out of the commit message or something else equally crucial. You can edit. I wouldn't recommend that one, you can. Squash and fix up do the same thing. So I use fix up, usually, and I use it mostly in the following scenario. In my commit history, you'll see a commit that said, Lorna fixed the bug. And then the next commit says, Lorna really fixed it this time. So if you haven't pushed yet, you can do Git Rebase Interactive for like the last 2 commits, and do fix up, which will just squash that second commit into the one it should have been in the first place. Also useful for Lorna made an awesome feature. Next commit, Lorna now has remembered to include the new template files. This happens to me all the time. Kind of depends. Like at work, I wouldn't worry about it too much. If I'm doing really well-paid consultancy, probably going to fix my commit history. It depends. So we can fix some things up, we can remove things, we can move things around. So let's do some work on this. Feature 1 is awesome, but it should have gone in much earlier. So I'm going to make that happen first in history by just putting the line at the top of the file. That said, feature 3 really wasn't a good idea. If I remove that line, that commit never happened in the new version of my branch. These app changes were cute, but it's come in 4 commits, and it just doesn't need to at all. So I'm going to squash that down. App 3 is OK, but I'm going to combine app 4, app 5, and app 6 by using the let's use squash. You can also abbreviate just with a single character, which is what that's showing you there. So the instructions tell you which prefixes you can change. And you should know also that you can reorder these lines and remove them. So now I'm going to have feature 1 happening first, app 3, a combination of other app commits, and then feature 2, no feature 3, and feature 4. All I have to do is save and close this file, and Git will then whoosh off and do all this for me. Because I chose to squash, I have the opportunity to rewrite the commit messages. So it's prompting me now and showing me what the previous commit messages were. So we'll just put something really meaningful in here, because I am fabulous at this. And there we go. So look at my log now. Let's just steal that. Come on. There we go. So now you can see that I've got, a couple of interesting things going on. Let's just git log on one line for a moment. How confused are you? There we go. So this is what I've just done. Look at where I rebased. Feature 1 ended up much earlier in the history. App 1 is still there. App 3, sorry, I can't read this from here. App 3 is still there, but 4, 5, and 6 are now in a single commit, which is really useful for when it just takes you a few commits to really nail something. And then I kept feature 2 and feature 4, but not feature 3. So that's Git Rebase Interactive. I have rewritten history. The reason that my combined log looks very interesting is because I had already pushed my branch to master. And by rewriting history, I have diverged my master and origin master. So if I want to push this now, I can't. All right, blatantly, you can push with -f. And you're all going to go back to the office and say, Lorna Jane said we could push with -f. Do you know what? You can push with -f if you understand what's going on. If you already pushed, that doesn't matter. If you already pushed and somebody else pulled it, that probably does matter. In the situation where you are the victim, if you like, of push -f, so you were perfectly following the rules and someone else has force pushed to a branch that you were using, well, you can either counter push.f-f, but probably you should like sit down over a cup of tea or something and try and sort that one out. Can't believe I'm giving you this information. All right, next. But what you actually probably need to do, if somebody has pushed with force And it makes your branch look like this. It's diverged. You do another, it's a reset hard again. You need to git fetch to find out what the remote branch is up to, and then do git reset -- hard origin master, or whatever the remote and branch name is, to bring yours into sync with theirs. So if there's a reason on your project why you need to push with force onto, say, the master branch, then everybody else can just get their master branches back in sync by doing git reset -- hard origin master. Brings everybody back to where they need to be. Okay, how are we doing for time? Horribly, actually. Oh, well. Let me pick. Right. I want to talk about Git Diff. This is interesting because you probably think you know how to diff. I have a couple of things that I do use that I want to share with you. So this is an empty repository called Diff, a couple of commits, and then editing both those files. So I have committed files with local changes. Git status. One of them is staged, and one of them is not. Git Diff, let's just try and get this so you can all see. Git Diff by itself only shows me the unstaged files. So Git Diff on its own gives me things that you haven't remembered to include in your next commit. Also remember that Git Diff won't show you new files, so you need to spot those in Git status. If you want to see what is in your next commit, which I find immensely more useful, then you need to do git diff -- staged, and this will show you the things that are going to be in your next commit. So if you've added a few things and maybe you got interrupted, then you can do git diff -- staged. What am I about to inflict on the world? And remember, I already said you can do the git reset with -p, so if you need to just pull a few things out and add something, you can very much shuffle those things around. If you want to see everything that's happened since the last commit, then you can git diff against head. Head is a revision number, which always means the thing I last committed, and therefore the thing that will become the parent of my incoming commit, my next commit. So that shows me both changes, git diff with head. Another way of looking at diff other than this kind of inline Ascii kind of view, most of you probably have some kind of GUI tools. My here source tree is very good. I use Meld. You're about to see it. There are other ways that we can look at this. Everywhere that you can do diff, you can do diff tool. So git diff, oh, this is a bit hard to read, git diff tool, and it will pick a different thing which you can configure. Mine's currently configured to vimdiff, so it shows me the two files side by side. Can be super helpful. You can also configure this. So another option for me, and something that I use a lot if I'm dealing with really complicated changes, is git setting diff.tool defines what diff tool runs, and setting that to Meld. So if I now do that git diff tool head again, this time it opens it in a bit more of a GUI editor. And again, same as vimdiff, you can move changes from one side to the other and inspect and compare them. Meld also has a mode where you can get it to show you the whole diff, and it opens like a tree with just the changed files. So you can see there's a database patch, there's a controller change, and there's also two template changes. And it shows you just those files and lets you open them in side-by-side view as well. All of you should have access to tools that do this. Your IDEs will do this, source tree will do this, Meld is cross-platform. Be really certain, because especially when you get beyond doing a bit or working on your own, and you start looking at reviewing big incoming branches, other people's work, really collaborating, those diff tools will make all of the difference in your confidence, but also in how quickly you can get things done, which is nice and important. Right. One more diff-related trick. And it's, I want to really show you what Git can do with file types and Diff. It's called Diff tool. This does a bunch of things. So first of all, it's moving a Git attributes file over into my .git attributes file. .git attributes is a bit of a weird one. It just affects your local repository, so it's not included and committed when you share, and it can dictate how all kinds of things work. In this case, I'm saying, I'm outputting the file there, all star.odt files, that's open document text, right? I'm a Linux user, it's LibreOffice. All ODT files should be diffed as in the ODT category. Then I put an extra entry into my Git config saying ODT files are binary. If you have a file type that is like the Minified CSS stuff tends to do this, that kind of looks like text except makes no sense when diffed, you can just categorize it as binary and Git will just tell you these files have changed and stop trying to show you the whole diff and making it impossible to read. So that's really useful. I've also used this text conf setting, which is saying, here is a program that knows how to render files in this category as text. So it's going to allow me to diff files by converting them to a textual representation. And here is a document that I made earlier. So I've got the document and I've committed it. It has to be committed for me to diff it, right? So it's in. Here it is. So we'll edit this document. It is a document. It says this is a document. It has some content in the document. And I will now edit the document. This is so exciting. I'll probably then give you a vim command to close it, because I find this incredibly complicated. There we go. Git status shows us the file has changed. Git diff gives me the text rendering, including the diff, of the changes made to that document. This is sometimes helpful if you do have like a PDF handbook or some kind of rich text thing. It doesn't come up loads. More often, you're likely to need the binary setting, because although Git has extensive knowledge of a load of file formats, specialized projects are very likely to have some custom ones. So you can mark it as binary just to stop it showing up in your diff. It's irritating. And if you want to, if there's a way, if it's text-ish, find a text conversion handler and set it up like this. It's super helpful. And I do have some repos which are sort of mixed. So I find that very good. Oh, some of you are still awake. I'm determined not to run long because I'm between you and your lunch. So I want to tell you all of the things, but I don't want to make you miss out on your food. So I'm just trying to balance that out over here. Let me show you a trick. This trick is called Git Bisect. And it's almost an implementation of a guess the number game. Right, so guess the number between 1 and 100, and I'll tell you higher or lower. So you're all immediately going to start at 50 in an effort to reduce the search space. That's Git Bisect. You're going to use it in a situation where you know something's broken, you know what is broken, but you have no idea when it broke. And you need to kind of find that root commit and fix it. So here is a hypothetical situation. We've got a bunch of commits. And at some point in history, I have no idea when, it's a massive history, we have accidentally deleted a file, and we've only just noticed that that's a problem. And I can't possibly guess from this history of commits when that would ever have happened. So I'm going to use Git Bisect to help me to find it. The way this works is we start by saying Git Bisect start. So we kind of get into bisecting mode. And my prompt reflects that. I'm going to say, oh, I need that log command again. No. I want all of it. Right. Git bisect. So it was fine somewhere like really early. Git bisect good. Let's just go for the second commit there, 2B, 4D, yeah, whatever. And it's currently broken, so I'm going to say git bisect bad. If I omit the commit reference, it assumes that I mean head. So it's currently broken. Off it goes. So it tells you how many revisions are left to test, how many steps it thinks it needs to narrow that down, and which commit it's currently on. So this is basically doing what you would do, which would be like, okay, well, let's try 3 weeks ago. And you sort of check out this revision and maybe poke at it, refresh the page, whatever it is you need to do to verify if that bug exists. In my case, I'm looking for, does the file stuff1 exist? Okay, the bug is we deleted stuff1, right? So I can test for that. Let me show you this, give you a sense of where you are. But Git Bisect Visualize shows you where we are. So that top pane shows you these are all the commits, and you can see we're currently in the middle. And then it'll show you I've eliminated these ones, and now I'm working on this section. So you can run Visualize at any point to kind of see how it's doing, where it's up to. I think this is Git K. So you'll have this on most systems. If you have something prettier and Git knows about it, it'll use that instead. Okay, so I can just test for this, right? This is super straightforward. And if you look closely, there's this test.sh file, which has mysteriously appeared in my directory, which just tests for the existence of stuff1.txt, and it uses the exit status of the script to say this is good, this is bad. You could do this by wrapping a PHP unit call, because its exit statuses will always be correct. You could use any of your other testing tools. Again, they'll return successful if it's cool, and not if it's not. So you just need a script that says yes or no, depending if the problem is there or not. Crucial thing to know, this script should not be under source control. Because if you put it in the newest commit, right, and then you check out some historical commit, it's not there. I can't run it. So if you need to copy your test or something, if you didn't have your test at the time that you broke this thing, then either don't commit it or just, it can't be in source control because you lose it when you go back in history. This is just hanging about in my working directory. So I can use my script by doing git bisect, run test.sh, and it goes through trying a bunch of different commits, and if you were to look at these on my history, it literally does, okay, it was working here, here, oh no, it was broken, found it. And it comes back and says, oh, it's the commit with the message, deleted a file. You would never have guessed, right? I just needed something really obvious so that I would know I'd shown you the right thing as well. So that's Git Bisect. I don't always use it with a script, do a lot of web stuff, so sometimes I'm just refreshing the user interface. But it does the efficient, which commit should I try next, how to reduce the search space thing for me. So that can be, I wouldn't say use it every day. I do work on some quite legacy code, but it's not that bad. My current colleagues are fine. It's just some of these projects have a difficult history. But sometimes it's allowed us to very quickly pick up on what went wrong and fix it, which is nice. All right, let's go with submodules. Oh, let me just stop bisecting. There we go. Awesome. I want to talk about submodules. Now, submodules don't have a good reputation. I think it's because there are quite a few moving parts. So especially if you work with people who are less experienced in Git, I find that I normally then need to write a cheat sheet on how to make sure that everything is pushed and committed that should be. I love submodules. Think they're a fabulous feature. And this is coming from someone who was a Subversion power user and liked externals and kind of hated submodules for a while. I love them, I love them, I love them. And there's a bunch of things you can do instead. You guys are big into modern tools, so you have Composer, so there are lots of reasons why you can just rely on your own Composer branch, and that's also awesome, and I do that as well. But sometimes I just need to work on this code in the context of this project and make the code available elsewhere to be reused into other things, but the hacking is happening here. And in that case, it's probably this project that's going to use the submodule, and others may pull in the branch dependency with Composer. I'm using this quite a bit at the moment with Hubot, doing a bunch of Hubot things, and I want those plugins that I write to be available to other people, but they're kind of, Like, the Hubot plugins are just not as stable and mature as you would think. So I constantly have to hack them, and I think I always want them available to other people, and I use them in a bunch of different Hubots, and so that's all done with submodules. So I think it's awesome, and I want to show you how to do it. I'm just going to cheat and set this up quickly. So I'm initializing a repository called submod, making some changes in it, and cloning into a bare repository. So I've got a working repository in submod, and then I've got main mod, which is where my module lives. So that's like the server thing that we're going to pull from. Now I've got modules. That's the name of my parent project. I definitely feel like naming things is hard right now. OK, so that's the name of my parent project. And I've got some commits in my parent project. Nothing else has happened yet. At which point, I add a submodule. Git submodule commands are one of the few places where it matters where in the hierarchy you are, like where in the directory structure you are. So you need to run these from the top level. And I am adding git submodule called submod on the repository, and again, it's a file repo /main-mod.git. That could be a GitHub URL. It could be pointing to your work GitLab, whatever, wherever you keep your code. In this case, mine's all local, so that if I go places without working Wi-Fi, it's not a problem. And git status shows me, first of all, there's a new file called submod. You would expect that to be a directory. It is a directory. Git's just showing it you as a file. And there's also a new entry in .git modules. And if you have a look Git modules, that describes my submodule. So it's called submod, it's in the submod directory, and it links to that URL or otherwise remote. OK, so we'll just add this. Now it's staged, so we'll commit it. Awesome. OK, so if we're actually in the submodule, everything looks quite different. Here I've got some files. I can edit a file. Git status shows me the file is modified. But if I go up into the main project, so out of my submodule into the module itself, Git status shows me something's happened over there. It's just like that thing something happened. And it keeps this really kind of isolated way of working, that the parent project kind of knows that something's going on over there, but it can't show you what's happening inside that directory. It's a very black box, which I think works really well. So we go back in here. I've got my edited file. I can add it. Yeah, nice. I'm so good at this, right? And we can push this up to our repository. So we created a submodule of a repository. We pulled it into our project. We made changes inside that. We pushed it back to its remote. Now in my parent project, we're still kind of seeing something happened over there. And all we need to do here is git submodule update. And it pulls the newest, because we're tracking the tip, right? So it pulls the newest and accepts those changes. So I can just make a change in one project, update that submodule, fix something maybe, fix a bug, and then make that available to all the other projects that use that same submodule by just doing git submodule update. So feel like there should be more to say about submodules. It should be big and complicated and hard, and it isn't. You need to pay attention and make sure you are pushing from your subdirectory as well as any changes in the parent project, and that is usually where things go wrong. But otherwise, when you clone, git submodule init, and then all the time, git submodule update, and that will pretty much keep you in sync and working together. OK, well, I am pretty much out of time. They're looking at me. OK. So I am pretty much out of time, but I am really happy kind of to chat with you through the day. I am here all day. I enjoy talking about this stuff far too much. So please, like I don't know very many Laravel people, but I'm excited about it. You're lovely. So talk to me anytime. I'd really appreciate your feedback on Joined In. Regarding this talk, except I'm the maintainer of that project, so you can talk to me about Joined In itself if you would like to. I teach extensively on Git, so you can get my LeanPub Git workbook, which is many small chapters with practical exercises that you can quickly learn a thing from. And there's also a video course with O'Reilly. And if you need any more serious help, then you should use git.scm.com, because it's the official reference. And with that, thanks very much. Enjoy your lunch.